Okay. What value is stored in result? So we go by the order of operations. 3 times 6 is 18. 18 divided by 4 is, in terms of how we do it, it is 4, because it's converted into an integer value. 4 minus 3 is 1. 13 minus 1 is 12, so we get E12. Let's suppose that addition and subtraction had higher precedence than multiplication and division. Then the expression would evaluate to which of the following. So 2 plus 3 is 5. 7 minus 4 is 3. 3 plus 8 is 11. So 5 times 12 is 60. 60 divided by 60 divided by 11 is 5. So we get 5. C. We get C. Which is true of the following Boolean expression? Let's see. It will always evaluate to false. Is that true? No, because there are some values of which it can be evaluated to true for. It may evaluate to false for some values of x. That is true. It will evaluate to false only when x is 0. That is not true. It will evaluate to false for some values, for some other values as well. It will evaluate to false only when x is very large or very close to 0. That's not true. It doesn't have very large. It will always evaluate to true. That's not true either. So we get B. Let x be a variable of type double that is positive. A program contains the Boolean expression. So it's asking us what's the reason that the above expression returns value false. So let's see why it could be. Math.pow returns an int, while math.square returns a double. That's not necessarily why, that's not necessarily the case. X was imprecisely calculated. Well, we don't really know how it was, we're not the, it's not imprecisely calculated. The computer stores floating point numbers with 32-bit words. Now, is this true? We learned that how the computer stores floating point numbers, and that is not how it stores it, or at least that's not the reason why value is false. There's a round-off error in calculating the power and square root functions. Now, we learned about round-off errors from before when learning about primitive data types. So this is the answer, because we learned about how the round-off errors can occur, particularly in this case. So it's D. What will the output be for the following poorly formatted program segment if the input value for num is 22? So if the value is 22, remember that for nested if statements, if you're not careful, the else is going to be tied to this one instead of the first one. So the else is tied to the second if statement. So 22 modulus 5 is equal to 2, not 0. This doesn't execute and it goes to the else statement. So it prints out num plus is negative, so it's going to print out 22 is negative, and we see here 22 is negative D. What values are stored in x and y after execution of the following programming segment? Well, let's see. Is x greater than or equal to 0? Yes, it is, so it goes here. Is x less than or equal to 100? Yes, it is, so it goes here. Y is equal to x times 3, so y is equal to 30 times 3, y is equal to 90. If 90 is less than 50, which is not, does not execute this, and we don't go here because this was true, so we get x is still equal to 30, but y is equal to 90, so it's A. Which of the following will evaluate to true if only A, B, and C are false? So if A, B, and C are false here, A would be true, but the whole thing would still be false, but then it would still evaluate to true. Because B is false, C is true, C changed from false to true, so the whole thing is actually false, but then changes to true. And then this is also true, so the whole thing is true, not false. the whole thing is wait, no, the whole thing is false. Wait, it starts out as false. This starts out as false, and it changes to true. And this starts out as false. Now false and true is false, and false changes to true. So it's not this one. A changes from false to true, or true. So this is all true. And then we go to this one. So A or B. So this is all going to be false, but then we change it to true. So this is a valid candidate. And for this one, false, 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 false and false and false, true. So no, it can't be this one. And then false or false, or this would change to true, so it would be true, so it would be false. So C is would be the correct one. Assume that A and B are integers. The Boolean expression, this Boolean expression would always evaluate true given that, let's say given that A equals B. No, that's not the case, because we can see here that if that's not the case, and this, we know what it takes to be true, and that doesn't lie within the conditions. A is greater than B. Now this reverses A greater than B, and now if A was greater than B, A times B is greater than 0, but we don't know if B could be negative. So if B was negative, then it wouldn't be greater than 0, so it would be false. And same thing with A is less than B. If A was negative, this couldn't evaluate to true, evaluate to false. Now, if A is greater than B and B is greater than 0, here we can come up with a valid argument, because we can make sure that B is not a negative number, so it will this part will evaluate to true, and this part will also evaluate to true. So we get D, because this will always evaluate to true, and not this one, because B is a negative number and it will not evaluate to true. Given that A, B, and C are integers, consider the Boolean expression. Which will guarantee that the expression is true? Well, let's see. So let's say C is less than A is false. C less than A is false. So this is false. That means that since this is false, this whole thing would be false. So since this whole thing is false, it's going to turn it into true. And since one of these is true, we know that the whole thing is going to be true. So we know that it is A automatically right off the bat because of the chain effect that it has. In the following code segment, you may assume that A, B, and N are all type int. What happens if A is equal to B is false? Okay, if A is equal to B is false, if A is equal to B is false, then this would evaluate to true, and this could evaluate to true depending on the values. So this is variant depending on the values. So we don't know if statement 1 or 2 will be executed at any time, but we do know that either will be executed depending on the values. So that's why it is C. Given that n and count are both of type int, which statement is true of the following code segments? So for what's true about both code segments? Well, let's say n is equal to 2. So 1 is less than or equal to 2, 1 increments. We're going to print out 1, 2 for this one, because until it satisfies the condition, which is cannot be greater than 2. For this one, it's going to be 1 is less than or equal to 2, but with a while loop. It's going to print out 1 is an increment. It's going to print out 2. So it's actually going to print out the same thing, the same output as this one. So 1 and 2 are actually equivalent for all input values of n, which is the first choice we get here, A. The following fragment intends a user will enter a list of positive integers and terminate the list with a sentinel. The fragment is not correct, which is a true statement. Okay, what's a true statement? The sentinel gets processed. The sentinel will get processed here. No, it does not, because it can't get processed. The last non-sentinel value entered in the list fails to get processed. Is this the case? And we can see here, the last value entered still gets processed. So no. A poor choice of sentinel value causes the loop to terminate for all values that have been processed. This could be the case, but ideally it is not, because we don't necessarily have a poor choice of sentinel values. And then D, the code will always process a value that is not on the list. Is this the case? Now let's see here. If while value is not equal to sentinel, code to process value, user input. So yeah, because it's going to process a value that's not on the list, that's not equal to sentinel. So it's going to be D. Now suppose that base 2 binary numbers and base 16 numbers can be denoted with subscripts as shown below, which is equal to 3D hexadecimal. Now, to convert from 3D hexadecimal to binary, we would have to do a right to left operation, and if we did that, we would get 11101 binary, which is equal to A. A common use of hexadecimal numerals is to specify colors on web pages. Every color has a red, green, and blue component. In decimal notation, these are denoted with an order triple, X, Y, Z, where X, Y, and Z are the 3 components. Each an integer from 0 to 255. For example, a certain shade of red whose red, green, and blue components are 238, 9, and 63 is represented as 238, 9, and 63. In hexadecimal, color is represented in the form RR, GG, VB, where RR, GG, and VB are hex values for the red, green, and blue. Using this notation, the color 238, 9, 63 would be coded as EE093F. Which of the following hex codes represent the colors? The color 1420 and 255. Now, what so in this case, we notice that we convert 14 into 0E. So we have these 2 options right here, starting off. Then 20. We could change it up into 20 into so once we convert this into its proper values, we will get C, and if you remember, A is equal to 10, and so on and so forth. So the letters each have their own values, and we use those to convert from this form to other forms. In Java, a variable of type int is represented internally as a 32-bit signed integer. Suppose that 1 byte stores the sign and the other 31 bytes store the magnitude of the number in base 2. In this scheme, what is the largest value that can be stored as a type int? Okay, The largest value that can be stored as type int, if we remember correctly, was 2 to the power of 31 minus 1, because that was the max value for integer if we go back into the notes. And that's not necessarily something you should have to memorize, but it's just know that it's a very large number. But it's going to have a minus 1. It's not just going to be 2 to the power of 31. It's going to be 2 to the power of 31 minus 1. So what will be the output after execution of this code segment? Well, let's see. X equals 10, y equals 0. While x is greater than 5, which it is, y is equal to 3. While y is less than x, which it is, 3 is less than 10, y times equals 2. So y is equal to 3, which is y is equal to 3. 3 times 2. So you're going to, y is equal to 6 now. If y, which is 6 modulus 10 is equal to 1, y plus equals x. So this is not the case. So we just go on to the back here. So what's going to end up happening is you're going to run this. You're going to run this through, and what happens if it prints out x and y? So each time as it runs through, x is going to x is going to be set equal to x minus 3. So the first time through it's going to be set equal to 10 minus 3, which is 7. So x is going to be equal to 7. So 7 is greater than 5. Y is equal to 3, while y is less than 7. Now y is equal to 6. If y modulus 7, 6 modulus 7 is equal to 1, y plus, so this is not the case, it's not execute. We minus, again, x minus 3. So now it's equal to 4. Y is equal to 3, y is still less than x, 3 is less than x, 3 is less than 4. Y times 2 is going to be equal to 6 again. So 6 modulus 4 is equal to 2. Yeah, so 6 modulus what is here? 4, right? 6 modulus 4 is equal to 2, y plus equals x. So in the end we're gonna get we get this, no, x is equal to 4, not 1. And the only option where x is equal to 4 is D. Which of the following values of num will result in valid having a value of true? Let's see this one. So which values of num will result in valid having a value of true? So let's try 6143. What this does is you put in a 4-digit integer. It returns true if n, a 4-digit integer, is valid, false otherwise. It checks the validity of its 4-digit integer parameter. So we're going to start with D1, D2, digit 1, digit 2, digit 3, check digit. So check digit is equal to n modulus 10. So let's start with this one. Check digit is equal to 3. And then n remaining is equal to n divided by 10. So that's going to be equal to 614. this would be 614, and this would be 3. Then we go to D3 is equal to n remaining divided by modulus 10, which is equal to 4, and then we go here, divided by 10, you get 64. Then you go here, 64 modulus 10 is equal to 4, n remaining divided by 10, and basically just goes on until D1 plus D2 plus D3, so that's what that is equal to. And it's gonna, it won't check out to having value of true, so let's go on to B. 6144. Now, 6144 modulus 10 is 4, and divided by 10, or 6144 divided by 10 is 614. Now D3 is equal to the n remaining, this n remaining modulus 10. So it's going to equal 614 modulus 10, which is 4, n remaining is equal to n remaining divided by 10, which is and we saw it here, n remaining is equal to this. So n remaining is now equal to 614. Oh no, I'm sorry, 61. So we'll keep continuing this out, and in the end you would see that return rem is equal to check digit. Now 21. Which of the following values will result in valid having a value of true? So of the following values, which one results in valid having a value of true? And I'm sorry, we just did that one. 22. What is the purpose of the local variable n remaining? What does it do? Let's see. It is not possible to separate n into digits without the help of the temporary variable. No, that is not true. N remaining prevents the parameter num from being altered. Let's see if that's the case. And no, that is not the case. N remaining enhances the readability of the algorithm. I suppose it kind of does. It does enhance the readability. On exiting the method, the value of n remaining may be reused. No, it may not. It can't be reused because it returns it. It returns from here. And then, n remaining is needed as the left-hand side operand for integer division, and no, that is not true. The only true one was C, and so that is the answer. What output is provided by the code segment? Let's see what the output would be. So this is basically nested for loops, kind of like nested if loops like we went over before. So it's gonna start out with this for int j is equal to I, so 5. 5 is greater than or equal to 1, and then 5 decrements. It's gonna print out 2 times j minus 1, so it's gonna print out starting with 2 times 4. It's gonna print out it's gonna print out 2 times 4, and then you go over line, so it's going to print that, but then you're going to keep going here. First, you're going to keep printing here until it satisfies this condition, and then you're going to go here and keep decrementing until it satisfies this condition. And once you keep doing that, you will get B, which you see as a a pattern of the way it was outputted. 5 times 1, 2, 3, 4, 5, and each time it was being decremented 1 less. Which of the following program fragments will produce this output? 2, 4, 6, 8, 10, 12. And ignore the spacing, let's see. Will A produce the this output? Let's see. It will run through this loop in about 6 times, incrementing each time. For 1 is for k is less than or equal to 6. You're gonna increment this each time. It's gonna print out 2 times k. So starting with 2 times 1. So ultimately it will print out this. Okay, so 1 is good. Now let's go to 2. So 2, similar to 1 except that it has 2 for loops inside of the for loop. And will this perform the same operation? Essentially, if you look closely, it's gonna k is less than or equal to I minus 1, and then here k is less than or equal to 6 minus 1 minus I. So the conditions are different, but they're printing out different things at the same time. So this is just printing out more of the minus signs, while this would be printing out the actual values. So it would go through until it satisfies the condition and prints out all the values similar to 1, and we will get this again. So 1 and 2 are correct. Could be D or E at this point. And for this one, 3 is very similar to 2. But in this case, it is I minus 1, k is less than or equal to I minus 1, and k is less than or equal to 6, and k is equal to I plus 1. So if we perform this, it's going to go through the iteration 6 times, and then come here, and it's going to perform it each time for 6 times, and we will get this output. So it is E. All of them are correct. Consider this program segment. What is a true statement about the segment? Let's see. If 100 is less than or equal to num, which is less than or equal to 1000 initially, the final value of new num must be in the range 10 less than or equal to new num less than or equal to 100. So if this is the case initially, the final value must be in this range. Now, if we look through here, is this the case? And no, this cannot be the case because new num would ultimately be less than the num. So here, there is no initial value of num that will cause an infinite while loop. Is this true? Can any value cause an infinite while loop? And no, it cannot. And because the loop is gonna exit at some point. And then 3, if num is less than or equal to 10 initially, new num will have a final value of 0. So if it's less than or equal to 10 initially, will it have a final value of 0? And yes, it will. So 2 and 3 are true, while 1 is false, leaving the answer to be D. And finally, 26. Which of the following replacements for code segment would cause the method to work as intended. So for this one we can do, let's see, would 1 only be the case? Would 1 work if we put it in here? We want to return that, we return n with its digits reversed. So if n is equal to 234, it returns 432. Now would this do the job? And if we look here, this is going to give us our digits not in reverse order. So 1 would not be the answer. Let's go to 2. 2, while n is not equal to 0, n modulus 10, or rev nom times 10 plus rem, and divided by equal to 10, so if we go through the loop, it will print it and output it in reverse order. And then for 3, similar to, it looks similar to 1 with a few alterations. In this case, in I is equal to n, I is not equal to 0, I is divided by equal to 10, rem is equal to I modulus 10, rev num is equal to rev num times 10 plus rem. So doing this, we would see that it would print it out in reverse order. So this is also true. So while 1 was false, 2 is true, and 3 is true. 2 and 3 are the only ones that are true, so the answer is D. Thank you for your time. I hope you enjoyed the video, and peace. See you guys.